Welcome back, everyone. Welcome to the Cloudology channel. My apologies for being completely late. Again, this is supposed to happen over the weekend. Got a little swamped. Someone visited me from out of town, so kind of had to postpone everything. And then I wrote to you guys on Sunday because I completely forgot to reschedule the stream for a day that I could actually do it, which is today, Wednesday at 9 p.m. Eastern Time, 7 p.m. for me. So I think that's kind of where I'm going to go with the schedule. I'm thinking Wednesdays just work out better for me. I don't have as much stuff going on for whatever reason. The middle of the week is like the least busy for me typically. But with that being said, what we're going to talk about today is what is the cloud? And you know, I'm sure if you Google the term "what is the cloud," you're going to come up with very technical definitions on what it is, why it's important, how to use it. A lot of buzzwords, a lot of acronyms, probably. I know because when I was getting in the cloud, I did the same thing, and that's what I got. That was my answer. There are a couple of helpful YouTube videos out there, of course, and I'm going to add to that hopefully. But essentially, the reason why I wanted to make this video or this live stream was because I wanted to break it down as simple as I possibly could, right? So if you're not a software developer, if you're not like really heavy into the IT space, if you're just coming into the IT space, um, I wanted to break that concept down of what the cloud is for everybody to understand as simply as possible. So without further ado, let's kind of get into it a little bit. So what is the cloud? If you open your browser and you type in a website, open your browser, whether it be Chrome, Firefox, you know, I don't know, Internet Explorer. That's kind of end of life now. Edge, Microsoft Edge, maybe. Brave browser, Tor browser for you naughty people out there that like to use Tor browser. And you type in, let's say youtube.com, right? You want to go to youtube.com. You want to watch your favorite video. Maybe you want to watch Cloudology again when I have more content on my channel, but that's another topic for discussion. So you go to this website, you type it in the URL bar, and boom, YouTube comes up, brings you to the YouTube home page, gives you a bunch of recommended pages and videos and stuff like that, right? And I don't know if you've ever wondered this, because I've wondered this at one point in time, but where does YouTube live? And what I mean by live is not like the actual, headquarters, like, company live. I mean, like, where does the YouTube website live? Where does the application live, if you will? Because I mean, most websites are pretty much just applications that run on someone else's computer, right? So if you notice, obviously when you open YouTube or a website, it's not like you're clicking youtube.exe if you're on Windows and opening the application on your computer and running the application on your computer, right? That's not the way we access YouTube through a traditional desktop Windows computer, right? So where is YouTube? What is it like? How does it just run in the ether of the internet, right? Well, you wouldn't be wrong in thinking that it does run on a computer, but just probably not the way you think about it. So obviously the CEO of YouTube is not running the YouTube application on their laptop or desktop. At least I hope not. Whoever the CEO of YouTube is, not sure. I'm sure I've heard the name. But where do they, host their website? Where do they host YouTube? Well, most likely, and you can probably confirm this, they host it in the cloud. And what does that mean when people say this website is hosted in the cloud? Essentially, all it means is it's hosted on a computer that is owned by somebody else, right? Most commonly Amazon now, so AWS. Amazon essentially, buys a huge plot of land, builds an entire warehouse on it, and puts a bunch of servers in it. Google does the same thing. Microsoft does the same thing. Cloudflare probably does the same thing. Alibaba probably does the same thing over in China or wherever their server farms are. And what a server is essentially, you can kind of think of it like a computer, except it's not like a traditional computer that is, you're maybe watching this on, or your desktop, or the computer you use at work or at school or at home, whatever the case may be. It doesn't typically look like that. Typically, it kind of looks like a very skinny, like Blu-ray player, and it has like a bunch of like Ethernet ports on it. I'm assuming that's what most of them look today. I don't know. I've never worked in a server farm. I've only worked in the cloud, unfortunately. Um, but essentially, that is the computer that all these applications run on, or all these websites run on. And what are those things? What are servers farm? I'm sure you've seen in movies like these buildings that have like a ton of like, oh, he's in the server room, and they've got like a tower filled with like servers that are all connected by wires and stuff. I think there was like a James Bond or Mission Impossible movie where they're like doing a shootout in a server room or something like that. Pretty sure you guys have seen some reference to a server room. Well, technically, that is the cloud. Although that was probably an on-premises type setup, but I'll get into that in another video. But for now, just imagine those servers were owned by Amazon or Google or Microsoft, and they're accessible to their customers, right? So people like me who build stuff on the cloud, or developers that want to host their website on the cloud and stuff like that, right? So that's the kind of the mental model I want you to have for the physical server. And as far as the less physical stuff, like actually hosting something on a cloud from like a user perspective, it's a little bit different. So if you think back to those server rooms that I'm kind of like walking you through and describing, it's primarily, that is, again, where your application or website is hosted, but it is the responsibility of the company that owns a server farm to kind of keep that up and running and to maintain it. So if you work in the cloud or you host something on the cloud, you're not expected to drive all the way out to the server farm and fix something if a network goes down, or a server goes down. That's not your responsibility. That's Amazon, Google, Microsoft's responsibility. They're in charge of that. But you can use the compute power from those servers to host your app. Not only compute compute power, but also their RAM, so their memory. It's kind of like those little cards that you would put in like a gaming computer or something like that. I'm pretty sure most people know what RAM, at least they've heard the term RAM before, random access memory. So their hard drives, for example, are also hosted in the cloud, and even databases are hosted in the cloud. And essentially what it is it's literally just Amazon loaning you out that compute power, or that, memory, or that storage space, or database disk space. It's literally you're renting out their computers to run your application. And essentially what that means is the only thing you're really responsible for is getting your application running and pretty much like securing it. And you're kind of, obviously you're setting up like the networking and stuff, which I will get into in another video. I really want to do a very in-depth video about networking, because I believe it's one of the harder concepts to understand when it comes to cloud, because without networking, none of your stuff works. Like, you can host an application, like in Amazon, for example, you can host an entire application on what they call an instance, which is an instance of a computer. Literally, it gives you a little virtual computer that you can run your application on, right? But it's not accessible to anyone, and including you, if you don't give it the right permissions, right? Which again I can get into in another video. But essentially, these cloud companies will charge you for usually compute power, or amount of uptime, or the amount of disk space, or the RAM you use. Basically, it's a pay-as-you-go type service, right? So it's kind of like a hand car wash, where you put in like a couple of quarters to get a certain amount of time, right? It's the same thing, except it's reversed. So you use it first, and they bill you for the time that you used it, or the usage statistics that you utilize in your application, right? So let me break down a couple of like very basic concepts about these computers that are out in the ether. or owned by Amazon or Google, right? So obviously that doesn't sound super secure, right? So if you just throw your application on the internet, anybody can do pretty much whatever they want with it, which is not cool most of the time. That's not really a best practice. Well, most cloud providers, and I know for sure, Amazon, AWS, and GCP have this. They have what's called a virtual private um, or virtual private cloud. It's called VPC. So you're going to hear VPC a lot, and it stands for Virtual Private Cloud. And essentially, what that is, it's a protected space inside of the computer that you're renting from Amazon, essentially. So it's not accessible by anyone outside of that virtual private cloud, so out of that network, because it's now a network, right? So ideally, you would tell Amazon, hey, I want a computer to run inside of this virtual private cloud so I can host my application or website or whatever the case, database on it, right? And Amazon, once you click the proper buttons, and I might actually go over that too in the future. That wouldn't be a bad video on kind of navigating some of these UIs for these cloud providers. Anyway, I digress. So you tell Amazon, like, hey, I want to put this computer inside this private space. So the only thing that can access it are what I tell it to access. So once you have that computer or instance, as it's called typically, it's called an instance inside of a VPC. You're going to have to allow access to that instance in order to get it, to basically access it from both your perspective, if it's in AWS, or from an external source like the internet. Like if you want a public website, you're going to have to open up, a certain network path that lets you into that instance and into your application, right? Again, I'm thinking of so many topics for so many videos right now. I'm trying to like condense this into something understandable. Okay. So you have this instance in this virtual private cloud on Amazon. I know it's getting deep already. It's already getting deep, but that's kind of how this stuff rolls. And let's say you have a database or another instance that these two computers, they need to talk to each other. Well, on AWS, for example, they don't come out of the box with that functionality. So they might be in the same, virtual private cloud, but they can't talk to each other without you as the cloud engineer allowing it specifically. Like, hey, I want this computer to talk to this computer, right? Typically, that's called a subnet. And a subnetwork is basically a network within inside of a network. So it's a network inside of your VPC that basically connects two or more computers together inside of this space, right? So, and then you can even granularly define that permission as well. So inside of that subnetwork, you can allow certain IP addresses to access that. So that's again, that's a whole nother video entirely, which I will make in the future. But you can also make it so that service or that instance is completely open to the internet and anybody can access it through any port. Doesn't matter, right? That's not the safest thing to do, but it will make your application public, right? You'll be able to, anyone will be able to access that instance. And there are quite a few reasons why you might not want that, which I will also get into later. But essentially, that's kind of what it is. It's literally just you're telling Amazon, hey, I want to borrow your computer and I want to run my application on it. And then you know what? You can just charge me for the compute power. Just charge me for the compute power as long as you keep that server running 24/7, 365. They're all cloud providers have some kind of like agreement where they're responsible for a certain set of things, like for example like server uptime. That's not really like, you're not going to drive to their server farm and then like plug in your server again if it disconnects, right? That's not your responsibility when it comes to that when it comes to that specific situation, right? Now you are responsible for like your own, application security, for example. You're responsible for your own application running correctly. You're responsible for, any bad actors that want to use your service, or whatever the case may be. That's kind of your responsibility, right? So that is the general, very, very general overview of like what cloud is. And I can explain some of the very like detailed things in a separate video. Like I'm going to do a specific video on subnetworks and identity access management, which is known as IAM. So that basically allows certain people, like on your developer team, or it allows certain people that are developing your app, whatever the case may be, or even certain services have access to your to your instance. And it also allows like certain tools to be used inside of the cloud environment. Again, I'm getting really ahead of myself because I get really excited about it if you haven't figured it out. But all that stuff is kind of interesting to me on how that works. But we're going to save that for another video. But there's also some other things that can also run on the cloud that might not be as straightforward. Like, for example, databases. A lot of cloud companies, like both Amazon and Google and Azure, they all have their own hosted databases, right? And basically, the idea behind that is they make it as easy as possible to just use a database. Like you don't have to spin up another computer and then run a database on it. Like go in there and be like, okay, I want to install MySQL, and then expose it on the MySQL port, which I can't remember what it is off the top of my head. SQL developers, you guys probably know the default port for that. But anyway, so basically what they do is they already have that kind of like MySQL, or SQL client that runs on their platform, and you're just like, hey, I want one of those, and you tell it, what size you need it to be, if you need it to be a terabyte or 500 gigabytes or 100 gigabytes even, and essentially they do all the work for you. They're you obviously you write the way you want to store things, but as far as the actual SQL instance, they do it all for you, and you just connect to it and start sending, your data to it, and start receiving your data from it. So there's no configuration on your end that you really have to do other than writing what's called a database schema, which is essentially just a layout on how you want that database to work, and how you want the data to be formatted, right? And there's also something called, like cloud functions, for example, in GCP, I believe it's called cloud functions. In AWS, they're called Lambda functions. And basically, those are primarily used for like if you just want to use one function that does something, like say you want to run I don't know, like a crypto trading bot, for example, that runs every hour or something like that, or runs every couple hours, or runs constantly if you want to pay for that. Um, Essentially, you can write a function in like Python. I think Ruby is accepted in some of them. Typically, the language is Python. And say you want to interact with a website, or maybe you write some crazy function that like notifies your desktop when you have to submit your timesheet for work or something like that. And you're running it on a Lambda function, and it runs like every day at 5 p.m. So it reminds you to do something every day. I mean, you could do that locally, or you could host it on the cloud, so it's always going to run no matter what, right? So there's also stuff like that on the cloud, along with a myriad of other things that we're going to get into as this channel progresses. But I need some topics for later, guys. I can't just sit here and explain everything in one video. And I don't think I possess the ability to do that anyway, to be honest with y'all. But essentially, that is what the cloud is. That is roughly how it works. Granted, there are some very specific details that are pretty important on that aspect. But that really sums it up for the average person who doesn't really know how IT works at all. Now, if you're a software developer, I can kind of explain this in a better way. If you developed software before, or you know how to code in some capacity, I'm sure when you create an application, you're going to run it locally, right? So let's say you do a create React app and you have a React front end. And where does it run? It runs on localhost port 3000 or port 3001, right? And it's still accessible through your browser. So you can go onto your browser, you can go to Firefox or Chrome and type in localhost with the little colon 3000, right? And it shows up there, right? Well, that is running on your computer. So that application is physically running your computer. It's using your computer's compute power. It's using its CPU. It's using its memory, and it's using its hard drive to run all this stuff, right? Well, take that exact same setup for the most part, that exact same local setup, and you give it to Amazon and say, hey, I want you to run this computer or run this application for me, right? Granted, you have to do all the configuration, you have to spin up those instances and stuff like that. Although Amazon and Google both make it pretty easy to do that nowadays, but um, essentially that same local development environment, you can actually run that exact same thing remotely on AWS or on Google. And that's kind of how you deploy a website. So if you're new to development and you haven't deployed a website yet, when someone says, oh, deploy it on AWS or deploy it on Google Cloud or deploy it on Azure, God help you if you have to deploy it on Azure. But when you deploy your code, typically you deploy it in a cloud environment, unless you're one of those super nerds that have like a huge little server room in your house, which stretch goals for one day, because I might actually be interested in doing that for my own personal reasons. But I digress. So that's kind of like an easy way for me to describe stuff for a developer, right? Someone who's got a little bit of got a little bit of skin in the game and understands how the development process works just a little bit. Even if you're new, even if you just learned how to code and you're making React apps, you're doing a bunch of to-do lists and you're doing everything on localhost, right? So another thing I wanted to talk about when it comes to the cloud is like why people use it. Why use the cloud? Why not just buy physical servers that you can manage in your house, in an extra room, or in your apartment, or in your garage, or wherever? Like, why bother with the cloud, right? Well, typically that comes down to scalability and cost, right? So servers can be pretty expensive depending on the hardware you're using. I've looked into it. I know servers aren't cheap. Another thing is scalability, right? So what do I mean by scalability? So in IT, typically if something is scalable, it means that you can add to it, right? So let's say your website that you deployed on let's say it's a home server. You have a home server and you deployed your website, it's publicly accessible, it's in use on your home server that you just happen to have, right? So you deploy it there, and now all of a sudden you get a ton of traffic. So people start visiting your website. You're getting like you made a viral video, and like your website's going nuts, right? And you have like 100,000 people a second trying to get to your website. Well, that compute power can only handle so many requests, right? That server can only handle so many requests. So what do you have to do in order to make that better, right? In order to not crash your server and bog it down. So you either have to buy more servers and distribute that traffic between like another server, or you can increase the hardware that the server is using. So you can give it more CPU. You can give it a better CPU. If you have like an i7 running in there, you can run an i9 and it's like this crazy computer, right? Or if you have like 4 GB of RAM, you can put a new RAM card in there and give it 8, so you can double the amount of RAM. But the problem is it's not fast. One, it's not automatic. Two, and it's not cheap to do that. Whereas on the cloud, a lot of that stuff can be configured to do it automatically. So like if your website's getting a ton of traffic, it can automatically either increase the instance size, so basically giving you more compute power and giving you more random access memory or more storage or whatever the case may be, and that's called vertical scaling. So there's a buzzword in case you're wondering what vertical scaling means. It means essentially you're giving that computer you're hosting it on more power. You're like, all right, I'm going from an i3 to an i9 because we got a lot of traffic, right? If you're a computer nerd, you should be able to understand what that is. But those little microchips that go in your computer, that is literally called a CPU. It's called a computer. So that's called vertical scaling. And then you have another type of scaling, which is called horizontal scaling, which is where you might not increase the resource amount. So you might not increase the amount of CPU cores that a computer's using, or the amount of RAM. You just want to add another computer of the exact same specifications, right? So now, instead of one computer handling all of the traffic, you can now distribute that load between two computers. And that way effectively cutting the load in half, right? And you can essentially do that pretty quickly. Same thing with, vertical scaling, depending on what kind of architecture you're using. But again, discussion for another day. But essentially, that's kind of what I mean by scaling. And on the cloud, honestly, sometimes it's as easy as clicking a button. Most of the time, if your company is really high speed, if you will, or if they've got their scaling processes down pretty well, it'll do it automatically to where you don't even have to worry about it. Imagine that. Imagine, like, boom, you get a bunch of traffic and your cloud environment is already ready to handle that because it scales up and down depending on load. Um, that's a possibility in the cloud. That's not really a possibility when it comes to something being hosted on a server you run in another room or in your garage or in the same room. You know what I mean? So it's not as easy to do as it is with the cloud. And so that's why a lot of people prefer doing it. Granted, you are, again, this is kind of like one of the drawbacks of cloud, is you are trusting Amazon and Google and Microsoft, which we all know they're not the most trustworthy people. And if you don't know that, boy, is this going to be a channel for you. You better subscribe. But you're essentially trusting them that they're going to be able to maintain a certain level of availability. They're going to not turn your app off because they decide they don't like it one day. So in that aspect, you're literally trading kind of like security for convenience, depending on what you're into and what you might be doing on the internet. You know what I mean? But we'll leave that for a possible roundtable discussion. But so yeah, that's essentially what the cloud is. That's why people use it. Also, forgot to get into cost. It is super, super cheap to run your applications on the cloud. It is incredibly cheap. Like, for example, I run everything I have on Google. I don't have a lot, granted. It's not like I'm running like, an enterprise level application, but I'm running quite a few websites and I'm running quite a few, customer websites and a lot of processes. I'm running on the cloud, and my monthly cloud bill is like $2. It's really not that bad, but it can get very expensive when you start reaching that enterprise level and you're asking them for a lot of resources. You're going to pay for it. You are absolutely going to pay for it. I've seen cloud bills get, into the hundreds of thousands of dollars very quickly for certain clients, but it's because they need that compute power, But anyway, I digress. I have given you a rough overview of what the cloud is. I hope this was at least somewhat insightful. I know I got into the weeds a little bit. I can't help it. That's just how I am. That's how I do things. I get into the weeds on things. But if you have any questions, feel free to put them in the comments because I will see them. I'll see every comment because I'm just like that. I look at every comment. I try to react to every comment. You can hit me up on Instagram, which I need to plug on this video description. So hopefully the link will be in the description for my Instagram after this video is over. And I'll answer them. And if you have questions, even next time I stream, so next Wednesday at 7, hit me up in the live chat and I'll try to answer your question as best as I can. And we can go from there. But as of right now, that's all I got for you guys. Thanks for watching. If you have any questions, like I said, hit me up. I'll be back next Wednesday, this same time, 9 p.m. Eastern Standard Time, 7 p.m. Mountain Time. You guys have a wonderful week/night. Bye.